Very good afternoon to all. I welcome you all for this today's lecture of industrial hydraulics and pneumatics subject. Okay. In the last lecture, we have discussed about the direction control valve. Okay, control valve of the hydraulic system, and that we have seen the classification valve. Then we have gone through the in detail about the direction control valve. Okay, for each and every type of direction control valve, we have seen the it's a construction, working, operation. Okay, and some animated videos also we have seen. Now today we'll go for another control valve, that is the pressure control, and after completion of the pressure control valve, we'll go for the last that flow control valve. Now before moving further, please tell me whether my video is visible at your end, my slide, my presentation, whether it is visible, and my audio is audible or not. Okay, just give me the confirmation message at chat box so that I can move further. Okay, so already I have given the definition about or to whom we should call the pressure control. That I have given the explanation. Okay, in the last lecture. Okay, but in detail we are going to study here. So we'll start with one small question, that is what is meant by the pressure control valve. Okay, so as the name suggests, pressure control valve. So as the name suggests, the pressure control valves are the devices which are used to control the fluid pressure in a system. Very simple. Pressure control valves are the devices which are used to control the fluid pressure in a hydraulic system or pneumatic system. If working fluid is here, that time you can call it as a pneumatic system. Getting it? Now, what is again small question, that is what is the function of this pressure control? Already I mentioned that to control the fluid pressure in the system. Okay, so these pressure control valves perform one or more functions. Okay, already I have given to control the fluid pressure. Along with that, also it performs one or more than one function. Okay, now which are that function? So it's a explanation I will give. So first function about the pressure control is to limit the maximum pressure in a various circuit component as a safety measure. Okay, as a safety measure, we need to limit the maximum pressure in a various hydraulic system or in various circuit. Getting it? So to limit the maximum pressure, you can use this pressure control. And another one function is that to maintain the desired pressure levels in various parts of the circuit. To maintain the desired pressure levels in various parts of the circuit. Okay, circuit means what? Hydraulic system. Okay, please remember that. And along with that, also we have some other function is that to unload system pressure. To unload system pressure. That is to change the direction of all or part of the flow. Okay, when the pressure at a certain point reaches at a specific level, that time to unload to change the direction of all, you can use also this pressure control. Okay, when pressure at a certain point reaches a specific level, that time we need to unload the system pressure. Means what? We need to change the direction of all parts of the flow or small part or part of a flow. That time also you can use the pressure control. And the last function of this pressure control is to assist sequential operation of the actuator. To assist sequential operations of a actuator in a hydraulic system or in a circuit with a pressure control. With a pressure control. Getting it? Now this is about the brief introduction of the pressure control now. All okay. Now, what are the different types of pressure control? That also we should know. Okay, so for that purpose, as per the standard or the depend on the function of pressure control. So these pressure control valve, in short, you can call PCV. So these pressure control valves are classified into or subgrouped into the 5 type. One is the pressure relief valve. Okay. Pressure relief valve, based on the actuation mechanism, uh, that directly operated pressure relief valve is there, and pilot operated, because we know that the mechanism of actuation, in that we have seen the paddle operated or the push button and the directly operated or pilot. So based on that also, pressure relief valve having two types. One is the directed, directly we can call it directly operated pressure relief valve, and another one is the pilot operated pressure relief valve. And the second type of the pressure relief valve is pressure reducing valve. Pressure reducing valve, getting it? And the third one, sequence valve. Okay. For each and every this type of the pressure reform, we are going to see it's a schematic, it's a principle, it's a working operation, and then application. Getting it? Then we have the another one, that unloading valve and counterbalance valve. So these are the 5 valves which are belongs to the pressure control valve, and these are the pressure valves are used in many application. Okay, in many circuit diagram, we'll get this types of the valve. Okay. Now, again in brief, I will explain the for each and every valve what is its function of the function. Okay, that we'll discuss. So for that purpose, I have included this slide I have taken from one book. So here I have mentioned the types of the pressure controller and their function. I have mentioned in front of that. So first is the pressure limited valve, or you can call pressure relief valve. Pressure limited valve and pressure relief valve both are same. Okay, so its function is to this relief valve limits the maximum pressure that can be applied to the part of system to which it is connected. Okay, relief valve limit the maximum pressure that can be applied to the part of the system which it is connected. Okay, if you want to limit the pressure of the any part of the system, then sorry, if we need to limit the maximum pressure that can be applied to the part of system, then you can use the pressure relief valve, or it is also known as pressure limiting valve. Then second, pressure regulator valve or pressure reducing valve, both are same. So its a function is to maintain the prescribed reduced pressure and its outlet. Okay, at its outlet. Okay, regardless of the valve inlet pressure, uh, if you want to maintain or if you want to reduce some pressure, that type pressure reducing valve or pressure regulator valve you can use. Then sequence valve. So sequence valve direct the flow to more than one portion of a fluid circuit in a sequence. Okay, then we have the back pressure valve, or it is also called counterbalance valve. Okay, in chapter number next, that is third chapter, we are going to see the counterbalance or unloading circuit or sequence circuit also we are going to see. That means the total system. So in that we'll have the counterbalance valve. Okay, so counterbalance valve, it permits free flow in a one direction and restricted flow in an opposite direction. Counterbalance valve. Okay, it allows or it permits the flow in a only one direction. It restrict the flow in other direction. Then we'll have the another one, unloading valve. So unloading valve allows pressure to build up to a adjustable setting. Okay, unloading valve allows pressure to build up to a adjustable setting. Then it bypasses the flow as long as remote source maintain the present pressure, preset pressure on the pilot port. Okay, then we have some pressure switch. Okay, that pressure switch also it belongs to the this pressure control valve. Okay, that pressure switch is used when pressure actuated electrical signal is required for a system control. That time it is used. Then we have the hydraulic flues also. So hydraulic flues employ the frangible diaphragm, okay, which establishes the maximum pressure in a hydraulic circuit by interrupting by repeating a preset pressure value. Okay, so these are some types of the pressure control law, and it's a in brief function. Now let us go for go in detail one by one. Okay. Now let us have a look on the first type of the pressure control valve, that is pressure relief valve. That is a pressure relief valve. Whether screen is visible, okay, clearly, because I'm not getting.
Yes, sir.
Yes, no, okay. Maybe due to some network issue, okay, at my device, it is somewhat blurred. Okay, now it is okay. Okay, so this is the first type of pressure relief pressure control valve. Okay, that is a pressure relief valve. Okay, now we have discussed some in the last slide. We have discussed all types of the pressure control valve and its a function. But for our syllabus, or we will discuss in detail construction operation of the few pressure controller. In that, we are going to see first a pressure limiting or pressure relief valve, then we'll go for the pressure reducing valve, sequence valve in detail. Okay, so this is a pressure limiting valve or pressure pressure relief valve. Okay, so again, the small question arises that what is the pressure relief valve? Okay, so this pressure relief valve, okay, it is also known as a pressure relief limiting valve. Okay, and it is a actually it is a protector of the our hydraulic system. See, whatever we have the hydraulic system or the hydraulic circuit, in that circuit or the system, there is a one wall. It is act as a protector, and that wall is known as the pressure limiting wall or the pressure relief wall. Okay, so this pressure relief wall, it limits the maximum pressure that can be applied to the part of the system. Okay, this pressure relief wall is limit the maximum pressure that can be applied to the part of system to which it is connected. Getting it? And in other words, I can tell this pressure relief wall, it protects the system from the excessive fluid pressure over and above the it protect the system from the excessive pressure over and above that system pressure limit is there. No, so for example, if system pressure is limited to 100 psi, then up to that psi value, pressure value, this pressure will this wall will operate. Okay, and if the pressure, if it is above than that time this pressure will actuate, and then whatever the excess pressure is there, no, that will reduce with the by actuating this pressure relief valve. Okay, so normally this pressure relief valve is located in between your pump and the actuator. Okay, this pressure relief valve actually it is located or placed in between the your pump and actuator. Getting it? So this relief valve protect the pump, as well as it protects the electrical motor and also some other components of the circuit. Okay, now again in that okay, in short, here I have written that this wall used to limit the pressure in the whole system. This wall is used to limit the pressure in the whole system, and also it is called safety wall or the maximum pressure wall. Also you can call it as pressure limiting wall. Okay, all names are same. Okay, and this pressure actually this pressure relief wall is normally closed types okay, it is okay at normal position, it is a closed. Okay, and it is as I have discussed that it is located between your pump and your actuator. Okay, again that before the directional control wall, that this pressure relief wall it is located. Okay, now there are again two types of pressure relief valves are there. Okay, two important types are there. One is a directly acting or directly operated pressure relief valve. It is also known as the simple pressure relief valve, and second is the pilot operated or compound pressure relief valve. Okay, directly operated or simple pressure relief valve, and second one is the pilot operated or compound pressure relief valve. Now first we will go for this directed operated wall. Directed operated wall. Okay, now the construction and operation of the this simple type of pressure relief valve, that is directly acting or directly operated type of this pressure relief valve. I will explain with the help of this figure. Okay, so you can see this figure. So as you can see in this figure, it has one port, okay, which is so okay, what I have discussed. So as we can see in this figure, so it has a one port, that is one inlet port. Okay, this one P. Okay, which is normally closed. You can see it is closed by this poppet. Okay, this is poppet. No, we can poppet or ball type. You can call a ball type or poppet type directly operated pressure relief valve. Okay, and this inlet port is normally closed. Okay, under the influence of this spring. Under the influence of this spring, you can see. Now this is a closed position. Okay, and it's adjustable. A spring load it is provided. Okay, so pressure value. Okay, for setting the pressure value, you can use this spring adjustable screw. Okay, spring adjustable screw. Getting it? Now how it is operated, or what is its operation, that I will explain. Okay, so when this inlet pressure, okay, what are the inlet pressure is there? No, okay, which the fluid will come from this port. Okay, P means what? Our pressure supply port. Okay, so when the inlet pressure overcomes the force exerted by this spring, no, that time wall opens. Okay, and this vent to the atmosphere or your atmosphere or to the pump, it is connected. No, so from this vent, fuel will go. Oh, sorry, this fluid will go. Okay, that means when fluid from this port, if its pressure goes more than the limited pressure, that time the limited pressure means what? This more than this force exerted by this spring, no, that time fluid will come from this port and it will goes will from this port. Getting it? So as this relief valve protects this other system or other element in the system from the excessive pressure by diverting the excess fluid to the pump, okay, by this port. Getting it? And this directly actuating or directly operated type of this relief valve have the ball or the poppet, okay, or this sliding spool working against this spring. Getting it? And as this inlet pressure decreases, no, when inlet pressure decreases, that time valve closes again. Getting it? That means spring will come to the its origin position, and this adjustable screw cap is there. No, you can see here adjustable screw cap is there, that is used to adjust the pressure limit and to vary the spring force also. Okay, getting it? And it's a graphical representation or the graphical symbol, standard symbol is like this. Okay, this flow will come from this side. Okay, and it bypasses or it will return from this dotted line. Okay, that means it will goes to the pump or that sump. Okay, and this is spring actuated now. Sorry, spring is used to do that only here, and this is a relief valve. Getting it? This is getting it? So this is standard symbol. Please remember, this is a directly operated. Now I will show the pilot operated. See, you can see that was the poppet operated here. This is also poppet. Okay, directly operated spring type. This is another image I have taken from the another book. Then I will show Now you can see where it is actually placed. So see, here we have the pressure relief valve. Okay, and this is the actuator. Okay, to lift the dead weight, that W. Okay, you can see here we have the pressure relief valve. Okay, you can see here pressure relief valve is used. This symbol, as we know that this is our pump symbol. See, now this is a pilot operated pressure relief valve. Okay, or it is also known as the uh, compound pressure relief valve. Okay, actually, this pilot operated relief valve, it overcomes the lecture झालं का? Hello. Okay. Actually, one thing is remaining to tell that the elimination of that simple relief valve, that is a directly operated pressure relief valve. So when in that wall, when the required system pressure is high, no, when required system pressure is high, no, that time shear spring is required. Okay. So because of the use of the heavier spring, problem of wall that chatter or the pressure fluctuation are very common in that directed operated pressure relief valve. So to overcome that problem, this pilot operated pressure valve is introduced. Okay, and this pilot operated pressure valve can be employed for a large flow rate and higher system pressure. Okay, so these all are built actually in two stages. Now you can see here we have the pilot operator. It's a symbol is like this. Actually, symbol is same. Huh? You can see what are the symbol here used. No, this one here. Getting it? Now let us move further. Okay, before going that, I will show a small video regarding this one. Okay, wait, so that it will be easy to understand. Just a minute. Huh?
Now, first we will go for the one small video regarding this or pressure relief valve.
Pressure relief valve is one of the most important types of safety valves. This type of valve sets a limit on the rise of pressure within a hydraulic line. In normal operations, the valve is closed and no fluid passes through. But if the pressure in the line exceeds the limit, the valve opens to relieve the pressure. This protects expensive machinery such as motors, pumps, and actuators from becoming damaged from high pressure. Without a relief valve, pressure can continue to grow until another component fails and pressure is released.
If there will not be pressure relief valve, the water will
Categories: direct acting or pilot operated. A direct acting relief damaged from high pressure. Without a relief valve, pressure can continue to grow until another component fails and pressure is released. Pressure relief valves fall into two categories: direct acting or pilot operated. A direct acting relief valve is held closed by the direct force of a mechanical spring. The spring force holding the valve closed is opposed by the system hydraulic pressure. The cracking pressure is the minimum pressure at which the valve will begin to open. This pressure is set by changing the tension in the spring using an adjusting nut or knob. As long as the system operates at a pressure at or under the cracking pressure, the valve remains closed. If the hydraulic pressure increases even a small amount beyond this level, the valve begins to open and fluid begins to trickle through. The pressure at which the valve is fully open is called the full relief valve pressure and is higher than the cracking pressure. When the hydraulic fluid in the system reaches the full relief valve pressure, the valve will be fully open and all fluid is discharged through the outlet port. A pilot-operated relief valve makes it possible to handle higher pressures and flow. It's also much smaller than direct-acting valves rated for the same pressure. This valve has two stages. The first stage is composed of the main valve with a poppet and spring large enough to handle the maximum flow rating of the valve. The second stage is composed of a much smaller, direct-acting pilot valve, which includes a pilot relief poppet, pilot spring, and an adjustment knob. This smaller relief valve is usually mounted crosswise on the main valve body. As long as pump line pressure is less than the relieving pressure set on the control knob, the pilot poppet will remain closed. Since the pilot poppet is closed, the pressure in the mainspring chamber is the same as the line pressure. Since these pressures are equal, there is no pressure drop from one side to the other, and the main poppet also remains closed. When line pressure increases higher than the relieving pressure, the pilot relief valve moves to its open position. This allows fluid to flow from the pressure side through the orifice and across the pilot relief valve to the tank. Once the pilot valve is open, there is now a pressure drop across the main valve poppet with a higher pressure on the pump line side. This causes the main poppet to move, allowing full flow through the relief valve. The same is true in reverse. As the pump line pressure decreases below the relief pressure set by the adjustment knob, the pilot valve will close. This allows the main spool to close and restores a balance of pressure. Relief valves can be used anywhere in a hydraulic circuit where it's necessary to prevent pressure from exceeding a maximum level. Advantages of direct-acting valves are their low cost and fast response times to pressure spikes. Pilot-operated relief valves are advantageous due to their smaller size and ability to work with higher system pressures and higher flows.
Okay. Understood? Understood or not? Just tell me. Understood or not? Okay. Now let us go for next one. Sure. Now let us discuss the pressure reducing wall. I will share small video. Pressure reducing wall.
In this video, I explain function, constructions and working of pressure reducing valve. So from the name, you can understand that this valve is used to reduce the pressure of oil and then after supplied it to the system. Pressure reducing valve is used to maintain the constant reduced pressure in the system. Okay, means they are used to reduce the pressures and maintain these reduced pressures inside the system. So then you think, what is the difference between this pressure relief valve and pressure reducing valves? Okay, so this pressure relief valve is used to relieve the pressures and then it is again supplied it back to the tank. Okay, means outlet of the pressure relief valve is connected with the tank. Okay, but in a pressure reducing valve, the outlet of the pressure reducing valve is connected with the system, means oil coming out from the pressure reducing valve is connected with the system. In earlier case of the pressure relief valve, that outlet is connected to the tank. Okay, and this pressure relief valve is normally closed type valve. Okay, and this valve is normally open type valve. So this is the basic two difference between the pressure relief valves and pressure reducing valve. These valves are used to limit the outlet pressures, means oil is supplied at the constant pressures to the system because the pressure limit are setted. Pressure reducing valve is normally open type valve. Okay, so they are normally open, means they reduce the pressure continuously and then supplied it to the systems. In pressure relief valve, they are normally closed type valve and they only open when the pressure is increased above the preset value. Okay, but this pressure reducing valve is continuously open. Open means they are reducing the pressure and then supplied oil to the system. It has an adjusting screw, spring, conical poppet fitted to a diaphragm as shown in this figure. Now here you see this figure, here the second image. Okay, so in this image you see this is the outer body, that sectional views indicate outer body. Okay, and here the conical poppet, this side is the inlet. Okay, and this conical poppet is connected with this spring and this spring is connected with the screw, means if we rotate the screw then the tensions of the spring is increased and we are able to set the pressures of this pressure reducing valves, and this side is the outlet.
Whether screen is visible, that video screen?
Yes, sir.
Okay.
Okay, and this is the symbol of the pressure reducing valve. Same way this figure.
Whether language of video, whether it is simple and understandable. May I continue? This may I continue this video?
It is also same type. Okay, so how it's work? So here you see this inlet is from this side, means this side is connected with the pump. Okay, it is mentioned here, and its outlet is connected to the system, means they are from this pressure relief valve, from the pressure reducing valves, the oil is supplied to the direction control valves and then after it is supplied to the actuators and different component of the system. Now if the pressure at the outlet is increased, the diaphragm is deflect upwards, due to which conical poppet will also move upwards to close the passage of working fluids. Means this poppet valve, this conical poppet is close this passage when they are moving upward directions. Okay, so here you see an image, it is the this side of the conical has the higher diameter, this side is the lower diameter. So when this poppet valve is moving upward and the passage is closed, when the passage is closed, the oil is not supplied to the outlet, means they are not supplied to the further systems. Okay, so if the pressure at the outlet is increased, means this is the outlet side. This outlet is connected with directional control valves. At this side, if the pressure is increased, okay, then what happen? When the pressure is increased, the oil is backflow to this pressure reducing valves, and they are try to move this diaphragm in the upper directions. Okay, so this horizontal line is indicate this diaphragms. Okay, so this diaphragm is moving in upper direction. Okay, then what happen? When this diaphragm is moving in upper direction, means this conical poppet is also moving in upper direction, because this conical poppet is connected with this diaphragms. Okay, so when this diaphragm is moving in upper direction, then the conical poppet is also moving upper direction, and when this conical poppet is moving in upper direction, this passage is closed, or the area of this passage is reduced, and the area of the passage is reduced means flow is reduced. When the area is reduced means flow is reduced and the pressure reduced to the normal. Once the pressures come to the normal, the diaphragm deflect downwards. So when the pressure is coming the normal, then the diaphragm is moving downward directions, means deflect on the downward sides, and the conical poppet move downwards, because when the diaphragm is moved down, then conical poppet is also moving in downward directions, and it's open the passage for the working fluid to the flow. Means when the passage is open, means more working fluid is supplied to the reduced pressure to the system. So this valve is called as the pressure reducing valve in hydraulic systems, and a pressure regulators in a pneumatic system. Means constructions and working of this valve are same, but this name is different for hydraulic systems as well as for the pneumatic system. For hydraulic system, its name is the pressure reducing valves, and for the pneumatic system, its name is the pressure regulators. So thank you for watching this video. If you learned something, then like the video and subscribe my channels.
We'll see animation of the pressure reducing one, so that it is easy to visualize that working.
Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com. This is part 1 on a pilot-operated pressure reducing valve. A pressure reducing valve is used to step down a higher system pressure to a lower maximum value in a downstream subcircuit. The internals of the valve don't really become active until there is considerable resistance on the outlet. The valve is not intended to be used as a flow control. It is a pressure control that can be used to limit the mechanical force of an actuator such as a cylinder. While many pressure reducing valves use a normally open or normally passing symbol, once active, the valve has to spend a fair amount of time in the closed position. If the valve was to remain open for any notable period, the full inlet pressure would quickly become present on the outlet line. Remember that there is no continuous flow path in this subcircuit to the cylinder. Observe here at the main spool opening. If we quickly increase the pressure setting of the valve, the spool is opened for a longer period of time in order to bring more of the inlet pressure through to the outlet. In future videos, we will look at the function of the pilot section and also how to troubleshoot pressure-reducing valve problems. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out
In this video, I explain constructions and working of sequence valve. So if you know the meaning of sequence, then you can easily understand the working and functions of the sequence valve. Sequence valve is
so
used
we
to
have
perform
pressure. We have discussed about the pressure relief valve. Okay, in that we have seen the directly acting, directly operated, and pilot operated. Then we have come for the reducing valve, pressure reducing. Okay, and now we'll go for the another one, that is sequence valve and loading valve. Okay, unloading.
two operations in sequence, one after the other. For example, the sequence valve is used in such a system in which more than one actuators is used in a hydraulic or a pneumatic systems. Okay, so suppose we consider it is a two cylinder is used in any hydraulic or a pneumatic systems. Okay, so for example, first cylinder will be extend, and after that means the in a first cylinder the extension is over, and after that means extension is completed in cylinder 1, then after cylinder 2 will be extend. It is called as the sequence, means the cylinder is extends or a retract in a proper sequence. It is called as the sequence. Okay, so this is the functions of the sequence valve, to operate the number of cylinder in a proper sequence. It has an adjusting screw, a spring, and a conical poppet, which are mounted inside the valve body as shown in the figure. Here you see image of sequence valves. Okay, in a sequence valve, here you see this one component is the adjusting screw. Okay, this is the spring and this is the conical poppet, and the sequence valve have a one inlet and it have the two outlet. Okay, means this is the one outlet, here one is written, here the two is written, so this is the two outlet ports. So number one outlet port is connected with the cylinder 1 and the number 2 outlet is connected with the cylinder 2. So it has one inlet port and two outlet ports. Outlet ports 1 and outlet ports 2, that I already explained. This is outlet port 1, outlet port 2, and this is the inlet port. When working fluid is supplied to inlet port of a sequence valve, it flows directly to the outlet port 1 and the first cylinder is extended. Means in an inlet port the oil is supplied from a pump. Okay, so when the oil is entered in these inlet ports, from these inlet ports it is supplied to the outlet port 1. Means from the outlet port 1 it is supplied to the cylinder 1, and cylinder 1 is the extend. By completions of this extension of the first cylinder, pressure in the line is increased. Means suppose the in a cylinder 1 extension is complete, then the cylinder 1 is not absorb the more oils. Okay, then oil is coming back, and when the oil is coming back, the pressure of the oil is increased here. Okay, and when the pressure of the oil is increased here, this conical poppet is moving in upper directions. Okay, so pressure in the line is increased, and hence the poppet of sequence valve is lifted off from its seats, and it's allow the working fluid to flow to the port 2, hence the cylinder 2 is extends. So when the pressure is increased here, this poppet is lifted off and the oil from the inlet port is supplied to this port 2, and from the port 2 it is supplied to the cylinder 2, and cylinder 2 is start to extend. Okay, here the fluid word is used because suppose it is a used in hydraulic systems, or as well as it is also used in the pneumatic systems. Thus sequencing is achieved between the two cylinder, means in a two cylinder the extension is carried out in a proper sequence. Sequence valve can allow working fluid in a reverse directions from the port 1, means during the retractions the oil is coming back from the cylinder to the inlet ports, means here in a port 1. Okay, so sequence valve can allow working fluid in a reverse direction from the port 1, means from the port 1 the oil is coming reverse, but it does not allow reverse flow from the port 2. Retraction of the first cylinder is possible, but retraction of the second cylinder is not possible. Means suppose we use this simple sequence valve, and the retraction in cylinder 1 is possible, but cylinder 2 is not possible. Suppose means oil is coming back during the retraction stroke, then what happen? Oil is come here and poppet is sealed, means the oil is not go back. Okay, for solving that we need to put the one check valves. So hence the check valve is essential for the reverse free flow of the working fluid from cylinder 2 to the tank for the retractions of second cylinders. So sequence valve with integral check valve as shown in this figure. So here you see this one image. Okay, in this one image, in between this outlet port 1 and outlet port to 1, check valve is provided. Means when the retraction in a cylinder 2 is going on, at that time the oil is coming in this 2 port, and from the 2 port it is supplied to the port 1, and from the port 1 it is go back to the tank or a reservoirs. So thank you for watching this video. If you learned something, then like the video and subscribe my channels for watching the more video related to the OHP.
Okay, this was about the sequence valve. Now we'll go for last one, unloading.
In this video, I explain unloading valve means it is a one type of the pressure control valves. I explain its constructions and working in this video. So here you see this is the diagram of the unloading valve, and this is another image of the unloading valve. Unloading valve consists of an adjusting screw, spring-loaded conical poppet as shown in these figures. So in this figure here you see this the adjusting screw is provided. So adjusting screw is used to set the preset value of the some pressures, and this adjusting screw is connected with this spring, and the spring is connected with the spool, and then finally spool is connected with this conical poppet. Okay, so here you see this is the conical poppet, and this outer part is called as the body. And unloading valve, that is a 3 port is there. Okay, one is this inlet port, and inlet port is connected with the pump. This is the outlet port. Outlet port is connected with the reservoir, because its name is given the unloading, means they are supply oil back to the reservoirs. And here the pilot pressure is there, means it is also one type of the port, means this unloading valve is operated by using the pilot pressures or a drain oils. Okay, so the oil is taken from the some part of the hydraulic systems. Suppose it is used in pneumatic systems, then the compressed air is taken from the some part of the systems, and then it's applied here. Okay, and according to these pressures, this unloading valve is open and closed. Unloading valve is set for a less pressures, means it is set for the less pressure, not set for the higher pressures. When the pilot pressure is increased about its preset value, the conical poppet will be lifted off from its seats and open the connection from inlet port to the outlets. Means here you see this is the pilot pressures, and its pressure is increased about the preset value. Okay, means suppose we set the certain value by using this adjusting screw. Okay, this adjusting screw is used to set the pressures, and this pilot pressure is changed, then the set pressure, then what happened, this conical poppet is moving in a left side. Okay, when this conical poppet is moving in the left side, this spool is also moved and the spring is compressed, and the oil from the pump, means oil or a compressed air from the inlet port, is supplied to the outlet ports. Now again I use this same image for the more understanding. The valve has a 2 ports. One is connected to the tank and another is connected to the pump, that I already explained. Okay, this is the one port, it is connected with this pump, and another is connected with this reservoirs. The valve is operated by the movement of the spool. So here you see this spool is provided, and here the spool is closed the inlet and outlet, means spool in this position means no oil is passed from the unloading valve, means the spool is closed and unclose the valve. normally the valve is closed and the tank pot is also closed. So here you see this diagram is indicating this valve is the closed. So when the valve is on the normal condition, it's at the closed position. Means right now you see this diagram, it is on the closed position. Means oil is not supplied to the tank. These valves are used to permit a pump to operate at the minimum load. Means why unloading valve is used? Unloading valve is used to permit a pump to operate at the minimum load. It works on the same principles as a direct control valve, that the pump delivery is diverted to the tank when the sufficient pilot pressure is applied to move the spools. Means the oil is not supplied to the system when the oil is not required. Okay, so oil is not required at that time, the oil is supplied to the unloading valve, and from the unloading valve the oil is supplied back to the tank. Means overheating of the oil is avoided by using the unloading valve. The pilot pressure maintain the static pressure to hold the valve open. Means at this end of the pilot pressure side, we need to maintain the static pressure constant to open this valve. Okay, so when the here static pressure is maintained, up to that time this valve is open and oil is supplied from pump to the reservoir continuously. As the pressure is needed in a hydraulic circuit, means in a hydraulic circuit means in a some part directional control valves and actuators, the oil is required. At that time what happen? The pressure is needed in the hydraulic circuit, the pilot pressure is relaxed and the spool is moved down or a right side. So in this diagram you see the spool is vertical, so it is moved down, but in a horizontal case it is moved right sides due to the self-weight and the spring force. So in a vertical type it is moved down due to its self-weight, but in this horizontal type due to the spring force they are moving into the right sides. Now the flow is diverted to the hydraulic circuit. Means flow is not flow of the oils or a compressed air or a gas is not flow from outlet, means tank or reservoir, but it is supplied to the system where it is the required. The unloading valve reduce the heat built up due to the fluid discharge at a preset valve. So unloading valve is reduce the heat built up, means the temperature of the oil is not increased due to the fluid discharge to the preset pressure valves. So suppose this unloading valve is not even a hydraulic or a pneumatic system, then what happens? The oil is not supplied to the reservoirs and the continuously oil is coming from the pump and it is not used somewhere. Then what happens? The temperatures of the oil is increased. So we avoid the heat build up by using the unloading valves. So thank you for watching this video. If you learned something, then like the video.
So this sequence valve we're discussing with the sequence valve. Okay, please remember this symbol, standard symbol of the sequence valve. Okay, and it is used to supply the flow of the fluid to the second consumer or second. Okay, if the requirement of first is fulfilled now, that time it will go to the next one. It is a standard symbol. Okay, you can see the circuit diagram where this sequence valve it is used. So this we can call it the application of the sequence valve also. Okay, so here we have the sequence valve. Here you can see here I have this unloading also we have seen. Now let us go for the next one, that is a flow control valve. Okay. Flow control valve. So we'll start with the one basic question, that is what are the flow control valves. Okay, so these flow control valves are also known as the volume control valve. Okay, because we know that directional control valve controls the direction. Okay, pressure control the pressure controller. Now if you want to control the flow rate or the volume rate of the fluid which is flowing in the circuit or in the system, so it needs the control valve. That valve is called a flow control valve. It is also known as the volume controller, and these flow controls are used to regulate or to control the rate of the fluid flow rate of fluid flow. Okay, to regulate or to control the fluid flow rate. Okay, to different parts of the hydraulic system, you can use this flow control. Okay, and since this control of the flow rate is means by means of speed of hydraulic machine element which is governed. Okay, so that flow control valve are also known as the speed control or volume control, because to control the flow we need to control the speed. So we have to control the speed so that it is easy to control the flow. Okay, and the flow rate to a particular system component, it is actually varied by throttling or by diverting the flow. Now again, this flow control having the two basic types. One is the non-compensated, non-pressure compensated flow control, and pressure compensated flow control. Non-pressure compensated flow control and pressure compensated. Now firstly, we'll go for the non-pressure compensated flow control. Non-pressure compensated flow. And this throttling means what? By which orifice or throttle valves are used. No, it is called throttling. And that diverting means what? By passing it to the reservoir. Okay, using the flow control. So you can see this is one of the throttling, and it is symbol, standard symbol. You can mention, you can designate by this one. Now, as I mentioned that firstly we'll go for the pressure compensated flow control, non-compensated flow control. Okay. Now the question are again this non-compensated flow control. Again, it is grouped in two group. One is the globe wall and second is the needle wall. That also we'll discuss. Now, what are the non-compensated, non-pressure compensated flow control? That we'll see. So these non-compensated flow control are used where system pressure vary considerably and precise flow rate control are not required. Now that time you can use. Okay, and these valves operates based on the principle of the flow through the orifice. Okay, that will be constant. Flow through the orifice, if it will be constant, that time you can use this type of non-compensated flow control. Okay, that means pressure drop remains constant. For that situation, for that condition, you can use non-pressure compensated flow control. And all the simple valve, what are the such as globe wall, needle wall, butterfly wall, gate wall, and ball wall are the non-pressure compensated walls. Needle wall, ball wall, butterfly fly wall, then a globe wall, gate wall, ball wall. Okay. Now, in such, actually, what are the non-compensated walls are there? So in such wall, pressure, velocity, and flow rate will get vary. Okay, but sorry, it will not remain constant. Okay, but the orifice is there, no? The throttle wall or some come in this above wall. Okay, orifice throttle wall. Okay, now you can see the here orifice is there. Okay, so it's a standard symbolic like this. Now, as I have discussed that needle wall. So this is a needle wall. You can see here we have the needle wall, and it's a standard symbol is like this. Then globe wall. Okay, this is like this. Okay, fluid will come from this, and this here we have the globe, and fluid will go from this. Gate wall. You can see here we have the gate. Needle wall, needle throttle, globe wall, ball wall, gate wall. All are belongs to the this non-compensated pressure wall. Okay, in globe wall, flow rate can be changed by means of disc, okay, or plug or a ball, okay, which sits or nests against this seat, okay, as I have shown here. You can see we have the symbol, this standard symbol. This is a variable flow control. Variable flow control. It's a symbol. It's a diagram. You can see. And you can see where it is this flow control it is used. So here, with the help of this, I will discuss the application of the flow control. Okay, see here we have the actuator. Okay, it's a fast you can move. That is a extension stroke you can call, and here we have the flow control. Okay. Now we'll go for the another type, that is a pressure compensated flow control. Now again the question is that what are the pressure compensated flow control? So as we know that the flow rate through this any verified it depends upon the pressure difference between the inlet and outlet. Okay, so therefore a constant pressure drop across the wall verified a constant pressure drop across the wall verified is required, and to assure that accurate flow rate, this pressure compensated flow control it is used. Okay, and this is a schematic diagram or of the pressure compensated flow controller. Okay, here you can see we have the flow throttle wall, control wall here. Okay, pressure compensated spool is there. Here from this inlet we'll get the fluid. Okay, and it will go outside of by this outlet. I will show you the symbol. Okay. Pressure compensated flow control you can represent by this symbol. This is a flow control. If general flow control if you want to mention, then this symbol it is used. Then if you want to designate non-pressure compensated, it is represented by this symbol. Then pressure, see difference. Okay, it's a pressure compensated, and if you want to mention the pressure and temperature compensated, then it is represented by this one. Getting it? Please remember, just have a look. Have a look. Please remember these all standard symbols. Okay. So quickly we'll go through some videos. Okay. 1 minute. How control works, that I will show first.
Welcome to the video tutorials of mechanisms by me Müller. In my previous video the working principles of a needle valve has been explained. One of the biggest shortcomings of the needle valve is that it restricts the flow rate in both directions. When you use a needle valve for speed control of a piston of an air cylinder in forward motion, it will also restrict piston motion in return stroke. You can solve this problem by adding a quick exhaust valve at the inlet port of your cylinder. I will do an animation of this in near future. The other solution to put a check valve in tandem with needle valve such that check valve will be open in the return stroke of piston. Uncompensated flow control valve we are going to describe here is actually repackaging of needle valve and check valve combination in a single valve. In this animation, the high pressure flow going toward the cylinder is shown with green color, and the low pressure return flow is shown with blue color. By changing the needle position we can change the flow rate going toward the cylinder. This way the forward speed of the piston of a cylinder can be fine-tuned. On the other hand, the reverse flow goes over the check valve and needle valve combinations. This prevents the fine-tuning of the return flow, since we do not have any control over the flow passing through the check valve openings. Flow control valves have many applications, but they are mainly used in meter in, meter out and meter in out circuits. I will do animation of these three important circuits in near future. Also shown in here is a circuit symbol of a flow control valve. Thank you for taking.
In this video, I explained the two types of flow control valve. Flow control valve in short written as the FCV. First type is the fixed resistication and the second one is the variable resistication FCV. This is the symbol of fixed resistication FCV and this is the symbol of variable resistication FCV. So here you see this is one orifice, okay, and this line is indicating the flow of the fluids, okay, and it is a fixed, that means here arrow is not drawn, okay. So when the arrow is drawn, it is called as the variable resistication, means we are able to change this area, okay, that is called as the variable resistication. So first we understand the fixed resistication FCV. So from the name we can understand that we are not able to change the flow rate of the fluid, it is called as the fixed resistication. And variable means we are able to adjust the flow rates, okay. So how the flow rate is changed, okay, suppose we have some pipe or we have the water tap at our homes, okay, so we are changing the flow rate of the waters by the rotating the needle of the tap, okay. So when we rotate the needle fully, then the flow rate of the water is high. When we slightly open the water tap, the water flow rate is smaller. So this is a simple examples of the variable resistications FCV. So fixed resistication FCV, it is not a valve, it is simply a resistication with a small opening, means orifice. So in a pipe one resistications are put in, and these resistications small hole are provided, and these small hole are called as the orifice, that we already study in a fluid mechanics subject. When fitted in the system, means when the orifice is fitted in the system, the working fluid has to flow through this small hole. So this reduce the flow rate of the fluids, means by using this orifice or by using the fixed resistication FCV, we are reduce the flow rate of the fluids, but it does not have any means to vary the flow rate or to vary the area of the flow, because we know that in a orifice that is small diameter is there, okay. So we are not able to change this diameter, and if we are not able to change the diameter, then area is not changed, okay. So we know that the flow rate Q is equal to area into velocity, okay. So in any type of the flow control, we consider the velocity is constant, okay. So by changing the area, we are only change the flow rate, means if we increase the area, flow rate is increased, and if we reduce the area, flow rate is increased, okay. So by using this fixed resistication FCV, we are only able to reduce the flow rates. Now, so first we talk that in a fixed resistication we are not able to change the flow rate, but here the word is mentioned to reduce the flow rate of the fluids. How it is possible? Because in a, suppose the pipe diameter is the 1 inch, okay, and it is 1 inch diameter, one small hole is provided, okay. So we are able to reduce these flow rates. Now here you see this is the symbols of the fixed resistication FCV, okay. So here it is the orifice, and we are not able to change this area or a diameter, okay. So this is the symbol of fixed resistication FCV. Second one is the variable resistication FCV. So from that name we can easily understand that we are able to change the flow rates, okay. That is called as the variable resistications. So this valve has a hand wheel or a knob, okay. So one hand wheel is provided, okay. So at our home the water tap is there. It is the simple examples of the variable resistication FCV. So by using this hand wheel, we rotate the knob, okay, and when we rotate the more knob, the water is coming with the higher flow rates, okay. The knob is open slightly, then water is coming with the slow speed or a slow flow rates. So by turning which we can change the area of flow, means when we rotate the knob by using our hands, okay, so we are just changing the area, okay. So when we fully open the water tap, the area is fully open and the flow rate of the water is higher, and thus we can change the rate of flow of working fluids. Means by changing the area we are able to change the flow rate. So we know that the flow rate Q is equal to area into velocity. So we increasing the area, flow rate is increased, we reduce the area, the flow rate is reduced. So ordinary water tap is a better example for understanding the functioning. So there are many types and the many designs. Example are needle valve, gate valve, butterfly valve, diaphragm valves, poppet valve. So these are the various examples of the variable restrictions flow control valves. For that different types of the valve I make the separate video so you can easily understand it. Okay, so here you see the simple image of the variable restriction FCV. Here inlet is there. Okay, this is the outlet portions. This is the needles and here screw is there. And this is the hand wheel. So when we rotate this hand wheel, okay, this needle is moving in upper direction or a downward direction depending on the in which directions we are rotate. So here you see this needle is completely here, so these areas are closed. Okay, so when we rotate it and they are moving upper direction, so here the flow rate area is open and the fluid is flow from inlet to outlet. Okay, so we have a depending how amount of the opening is there. Okay, it is depend on the number of rotations of this wheel. That's why we are able to change the flow rate. So it is called as the variable restrictions FCV. So figure show a needle valve. It has a needle which move up and down by turning the screw. So that thing I already explained, this screw. So when we rotate it, this needle is moving up and down. This alter the passage for the working fluid to flow, which in turn alter the rate of flow. So by moving this needle up and down, we are change this area of flow here. Okay, and when we change the area of flow, we are able to change the rate of flow. So rate of flow Q is equal to area into velocity. Here you see this is the symbol of variable restriction FCV. Okay, so first we need to draw the symbol of fixed restriction FCV and then after one draw the one arrow line. Okay, then it is converted into the variable restriction FCV. So thank you for watching this video. If you learned something, then like the video and subscribe my channels.
Low resistance to piston advance.
In this video, I explained the plug or a flow valves. It is the one types of the flow control valve. The plug valve is quite commonly used valve. It also termed as the glow valve. Schematic of plug or a glow valve is shown in a figure. So here you see this is the figure of the plug valves. Okay, so this is the outer body part. Okay, this is outer body. Here you see this plug is provided. That's why it is called as the plug valve. And this plug is moving up and down by using this plug adjustment screw. Here you see the another image of the plug or a glow valve, and this is the third image. So in this middle image you see this is the plug, or it is also called as the valve members. This outer part is the body. Here you see this is the seat where the plug is sit, and this is the actuators or a stem, or a we also call as the screw. This valve has a plug which can be adjusted in a vertical direction by setting the flow adjustment screw. Okay, so here you see this is the plug, and this plug is adjusted in a vertical direction, means we are able to move this plug in a vertical direction, means up and down, by using this flow adjustment screw. So when we rotate the flow adjustment screw, okay, either we rotate in clockwise directions or either we rotate in a anti-clockwise directions. So depending on these directions, the plug is moving in up and down. So what happens when the plug is moving up and down? Okay, so the adjustment of the plug alter the orifice size between the plug and seat valves. Okay, so here you see this is, we consider this is the seat valves. So when this plug is moving up and down, the plug shape is the conicals. Okay, so when it's moving up and down, at that time here this passage is changed. Okay, so we know that the flow rate Q is equal to area into velocity. Means if this area A is increased, means this passage area is increased, at that time we are achieve the more flow rates. And when this area is reduced, then the flow rate is reduced. Okay, in this image you see this is the seat and this is the plug. Okay, so that's where the area is increase or decrease. According to this area, the flow rate is changed. Thus, the adjustment of plug control the fluid flow in the pipelines. Means by adjusting the screw, we are able to adjust the flow rate of the pipeline. The characteristic of this valve can be accurately predetermined by machining the taper of the plug. Means accuracy of this valve is depend on the machining of this taper. Okay, and the typical example of the plug valve is stopcock that is used in laboratory and glassware. The valve body is made of the glass or a Teflon. Means we are considering the example of the stopcock that is used in laboratories. Okay, that is a simple type of the valve is used. Okay, so in that the valve body is made of the glass or a Teflon. Means outer part is made from the glass or a Teflon, and the plug can be made of plastic or glass. Means this plug is either made from a plastic or a glass. Special glass stopcocks are made from vacuum applications. Means special glass is used when we need to use this plug or a glow valve for the vacuum applications. Stopcock grease is used in a high vacuum applications to make the stopcock airtight. So thank you for watching this video. If you learn something, then like the video and subscribe. In this video, I explained
Now lastly we will see the
generally we
one-
know the meaning of the time delay. Okay, so what is the meaning of time delay? That is a time between the two things. Okay, that is called as the time delay. So when we talking about the hydraulics and pneumatics, so time delay means there is a certain times between the two operation. It is called as the time delay. And for achieving this time delay between the two operations, we need to use the time delay valve. So this valve is used to have required amount of the time delay between the two operations that I already talked. For examples, a cylinder extend first and retract automatically after the preset amount of the times. So here we consider two operation of the cylinder. One is the extension and second one is the retractions. So when the extension is done, okay, so we are not required the retraction after the extension quickly, okay, but we need to provide some time delay or a time interval. Means suppose the extension is over and we need to hold the piston or a cylinders for a 5 or 10 seconds on the end of the extensions. Okay, then after we need to start the retractions. Okay, for that purpose we need to use the time delay valve. Okay, so it is not necessary just we use the 5 or a 10 seconds. We can set any value according to us requirement. Now here you see this diagram of the time delay valve. Okay, so generally this time delay valve is connected with the directional control valves. Okay, so here you see that is a P port, T port and the C port is mentioned. Either we consider it is the A ports. Okay, so this is the directional control valves, and inside this directional control valve here the spool is there and this is the spring is there. Okay, so we need to do the certain modifications in a direction control valve to convert in a time delay valves. Okay, so here figure show a time delay valve. It has a inbuilt reservoirs. Means here one reservoir is provided that is not seen in the image, and then after the flow controls, so here you see that the flow is entered, so inlet is from these sides. Okay, so this the P port is the inlet for the directional control valve, and from the P port the fluid is supplied to the actuators. Okay, but this is the inlet for the time delay valves. Okay, so we need to some fluids to control the time delay. So here the fluid is enters, here the needle is there. So by using this needle we are able to control the flow. That's why here the flow control is mentioned. Check valve. So here you see this check valve is provided. Okay, and pilot operated 3x2 direction control valves. So this is the pilot operated 3x2 directional control valve. Why it is a 3x2? Because 3 port is there and the 2 position is possible. When working fluid is admitted through inlet port of the valve, so here you see this is the inlet port of the valve. So working fluid is admitted through these inlet ports. Okay, then after where it is flow, these oil have a two options. Okay, either go through this flow control valve or either directly enter from the check valves. Okay, so when we supply the fluids, it enter into this check valve. Okay, so here you see that the reverse flow is not possible in a check valve, means from this chamber oil is not go back in these lines, because here check valve is provided, means fluid is enter from this side to these chambers. Okay, so here what I written, it flow through check valve, means fluid enter as a inlet is pass in a check valve, and from the check valve it's fill the chamber. So here you see this is the fluid is enters, and the fluid is start to fill in this chamber, and when the fluid is filled in this chamber, they exert some force on this spool. Okay, so this fluid is applied the some force on this spool, and the spool is moved towards the right sides, and here the some spring force is there. Okay, due to this the spool is pressed against the spring force and making the connection from port P to port C. So here you see there's the connection is made between the port P and C, means oil or a compressed air or gas coming in a P port, it's supplied it to the C port, and from the C port it is supplied it to the actuators, and the cylinder is extend. So its cylinder is extend, its actuator is extend. Suppose it is the rotary cylinders, then it is rotated in a clockwise directions or a anti-clockwise directions. Now next we understand how they are retract. Okay, so when inlet port is open to working fluid reservoir, means here reservoir is provided. Okay, so this inlet port is open. Okay, this is considered as the inlet port is open. Okay, so working fluid flow through the flow control valve slowly back to the reservoirs, means when this chamber is filled, okay, at that time the oil is go back to these inlet ports. Okay, so here you see oil level is reduced, and this oil is passed into these reservoirs through this part, means when this flow control valve is open, that's create the some pressure difference, and oil is flow in this direction, in downward direction. So here I written working fluid flow through the flow control valve slowly back to the reservoir. Pressure in chamber is reduced slowly, means when the working fluid is go from the chambers to the reservoirs, the pressure is reduced here. Okay, so when the pressure is reduced, what happens? Once the pressure become less than the spring force, means here this spool, on the left side of the spool there is oil pressure is there, and on right side there is a spring force is there. Okay, so which side the pressure is increased, the spool is moving on that direction. So when this pressure of this fluid is reduced than the spring force, the spool is start to move in a left directions. Okay, so once the pressure become less than the spring force, the spool is shift back, and to make the connection between C to T port and the cylinder is retract. So when this spool is moved left side, so this portion of the spool is come here. Okay, so C port is supplied oil to the tank or a reservoirs, and it is called as the cylinder extensions. Sorry, not extension, it's called the cylinder retracts. So thank you for watching this video. If you learn something.
Okay, so this is just a special type of a cylinder I have, special type of valve I have shown. Okay, so up till now we have discussed direction control, the pressure control, then flow control, and all the types we have covered. Okay, now in the next lecture we'll start our chapter number 3, and in that chapter number 3 we'll see the different hydraulic circuits. Okay, so I hope whatever up till now we have covered, everything you understood. Now I request you all, please write down your roll number in the chat box, and you can leave this meeting. Okay, see you tomorrow. All are requested to write your roll number in the chat box, and after writing your roll number in the chat box, you can leave this meeting.